Hello everyone. So today I'm going to talk about the how to delete a node in a linked list. So here we have a linked list, a single linked list, and these are the element in the linked list: 8, 3, 2, and 1. So let's talk about the representation of a linked list in the memory. So each element in a linked list is called a node, and each node has its value, which is called data, and the address to the next node. So here you can see we have these two fields in a particular node. 8 is its data, and 210 is the memory address of the corresponding node. So when we talk about deleting a node from a linked list, so there could be three possible cases. One, when you want to delete head. Second, when you want to delete the tail of the linked list, which is the end node. Third case is when you want to delete a node from the middle of a linked list. For example, it could be this. So what involves in a linked list when you are going to delete a particular node is you break the link from the, let's say for example, if you want to delete an nth node, so what you will do is you will break the link from the n minus 1th node to the nth node, and you will link it to the n plus 1 node. For example, let's say, so these are the positional index of the node starting from 1. So 1, 2, 3, 4, and so on. So let's say I want to delete a node at the nth position. In my case, the nth is second. I want to delete a node at second position. I'm talking about the third case here. So our job is to actually break this link and replace the memory address of the head node, which is pointing to the second node, with the third node. So you will have something like, this. So when you print this linked list for the next time, you will have these elements. Because we deleted this particular node. So if you're using Python, then the Python memory management is so efficient that it will be automatically deallocate this particular memory location the moment you dereference it. But if you're using a C++ or C implementation, then in that case, you'll have to deallocate this memory, because we don't want our the memory in the system occupied by unnecessary content that we don't want to use at all. So this was the case when we want to delete the middle node. So how about if you want to delete the end node? So all you have is, whenever you traverse a node, you will have the head node, the data which contains the data as well as the address to the next node. So you will traverse towards till the end, and you will check the memory address whether it's 0. 0 here stands for that we are not pointing to a valid address after this particular point. So the moment you figure out that this is the, by using a simple if condition, that if the address of that particular current node is null, or it's, let's say if it's 0, so all you need to do is, so you walk a little step back and replace the address field of the last node with 0. So this will become something like 2 and 0. So this particular node, when you were talking about the case when you want to delete at the end of the node. So what about if you want to delete the head of the node? So it's pretty simple. You have the head. All you need to do is you actually traverse a little one step ahead, and all you need to do is make your head to point to the second node. So it will directly break this particular link. So you just remove this thing from the whole linked list. So if you find the output of this operation, your linked list will be something like 3, 2, and 1.